Ever wonder how a machine, a thing of pure logic and math, can possibly understand something as nuanced and, well, messy as human language? It's one of the biggest questions in AI, and today we're going to break it all down. By the end of this, you'll see language in a whole new way, I promise. Think about it. On one hand, you've got us. We get context, sarcasm, poetry, no problem. On the other hand, you have a computer, which only gets numbers. Zeros and ones. That's it. So how do you possibly build a bridge between those two worlds? How do you translate the richness of a sentence into the cold, hard logic of mathematics? I mean, our language is just filled with ambiguity. The word bank could be a riverbank or a place you put money. It all depends on the other words around it. But for a computer, there's no room for maybe. It's all got to be perfectly precise. And that is the fundamental challenge we have to solve. So here's our game plan for today. We'll start with the basic problem, what we're calling the language barrier. Then we'll see how to turn words into numbers. After that, the really cool part, we'll create a map of meaning, figure out how to handle word order, and finally get to this profound idea that meaning itself is actually a form of geometry.
Okay, let's dive right into our first section, the language barrier. This is all about accepting one simple, kind of brutal fact about how computers see our world.
So here it is. This is the foundational rule for everything else we're going to talk about. A computer has absolutely no idea what an apple is. It can't taste it. It can't see its color. It can't feel its weight. To a computer, the letters A, P, P, L, E are just meaningless symbols. To make it understand our world, we have to translate everything into its language, the language of number. So how do we actually begin this massive translation project? How do we go from text to something a computer can even begin to work with? Well, it starts with a simple, almost mechanical breakdown. It's really a three-step process. First, you take the raw text, just as it is. Then, you break it up into smaller pieces we call tokens. These are usually just words or maybe even parts of words. And finally, you assign a unique number, an ID, to every single token from a gigantic dictionary. Let's see this in action. It's pretty straightforward. The sentence "market is bullish" gets chopped up into 3 tokens. The computer then looks up each one and finds its unique ID number. So market becomes, say, 1024, is becomes 56, and bullish is 8901. But, and this is the key part, these are just labels. They're like name tags. They don't have any actual meaning yet. And this is where things get really, really interesting. We have these meaningless ID numbers. So how do we breathe life into them? How do we give them actual meaning? Well, we create what you can think of as a map of meaning. The key to this entire map is something called an embedding vector. Now, I know that sounds super technical, but think of it like this. It's a long list of numbers, sometimes hundreds of them, that acts as a coordinate. It's not just a random ID anymore. It's a very carefully calculated address that represents a word's meaning and how it relates to every other word. Seriously, picture a giant, multi-dimensional space. In this space, words that have similar meanings like happy and joyful are located really close together. They're practically neighbors. And words with opposite meanings like hot and cold are super far apart. The embedding vector is the GPS coordinate that tells the AI exactly where to find any word on this crazy map. Now, if this is truly a map of meaning, we should be able to do math on it, right? We should be able to navigate it. So what do you think happens if we take the coordinate for king, subtract the coordinate for man, and then add the coordinate for woman? What concept are we even pointing to? The answer is queen. I mean, get this. This is absolutely mind-blowing. It proves these vectors don't just store definitions, they actually understand relationships. The relationship between man and woman is geometrically the same as the relationship between king and queen. The map actually works. Okay, we've given our words meaning, which is incredible. But now we have a whole new problem. You see, a sentence isn't just a bag of words. The order matters a lot. So how do we teach the AI about sequence and structure? Exactly. The AI understands the concepts of market, is, and bullish, but it has no idea which one came first. I mean, the dog bit the man and the man bit the dog use the exact same words, but their order creates 2 very different meanings. We need a way to encode position. And the solution is just so elegant. We take our original meaning vector, the embedding, and we simply add another vector to it. This new positional vector is just a unique numerical fingerprint that says, I'm the first word, I'm the second, I'm the third, and so on. So now our final vector contains both the meaning and the position, all baked into one. So let's put this all together now. We've gone from meaningless text all the way to a rich, position-aware mathematical object. Let's just trace that full journey one more time and see the final, pretty profound result of all this. Here's the complete assembly line. We start with plain text, we break it into tokens, we convert those tokens to simple ID numbers. Then, the magic step. We transform those IDs into those rich embedding vectors from our map of meaning. And finally, we add the positional vectors on top to create the final vector that the AI actually reads. So, the crucial point is this, and I want you to let this sink in. For an AI, language isn't a string of characters. It's a collection of points in a high-dimensional space. Similarity is just distance. Relationships are directions. Analogy is just parallel lines. Meaning has become geometry. And this is exactly why every single step in that pipeline is so critical. If you tokenize poorly at the very beginning, the AI starts off with the wrong concept entirely. If your embeddings are weak, the AI's entire map of meaning is basically useless. And if you forget to add position, you get total chaos. The quality of the final understanding depends entirely on the quality of each geometric step. This leaves us with a fascinating final thought. We've successfully managed to translate the abstract concept of language into the concrete world of geometry. So, what's next? Could we map emotions, artistic styles, or even complex ethical ideas in the same way? The journey to translate the human experience into math, well, it feels like it's only just begun.